this video, we are going to learn how to add and subtract rational expressions. To add and subtract rational expressions, you must have a common denominator, just like how you would need with regular fractions. So if I'm going to add 1/7 plus 3/7, we keep the common denominator of 7 and we add our numerator. 1 plus 3 is 4. So here our answer would be 4/7. The same is true with rational expressions. Here you can see I have a common denominator of x plus 7. So that's going to be the denominator of my quotient. And then I can add my numerators. X and 3 are not like terms, so you just leave it as x plus 3. So your answer would be x plus 3 over x plus 7. On example 1, it says find the sum. And I have 2 over x minus 1 plus 3 over x minus 1. I do have a common denominator of x minus 1. So that means I can just add my numerators. 2 plus 3 is 5. This is as simplified as this is going to get, so this is my answer. On example 2, again, I have a common denominator. My common denominator is 2x plus 3. Once you have a common denominator, you can go ahead and add your numerators. In my numerator, I am going to combine like terms. 4x minus 2x is 2x, and negative 5 plus 6 is positive 1. There's nothing that I can factor to simplify this, so this is my answer. 2x plus 1 over 2x plus 3. In example 3, again, I do have a common denominator of 2x squared plus 12x. So I'm going to go ahead and write that down as my common denominator. And because I have a common denominator, I can combine like terms. X plus x is 2x, and 6 minus 4 is 2. Now, just like with regular fractions, we always want to reduce when we can. In my numerator, I have a GCF of 2, so I can factor that out. And so inside parentheses, I'll have x plus 1. In my denominator, I have a GCF of 2x, so I'm going to go ahead and factor that out, and that's going to leave me with x plus 6. Now, just like how we did for multiplying and dividing fractions, you want to look for factors that are equivalent to 1 that you can eliminate. Well, 2 has a common factor in my numerator and denominator. So my answer is going to be x plus 1 over x times x plus 6. This is as simplified as this fraction is going to get. So this is how we add fractions when they have a common denominator. When your fractions do not have a common denominator, you'll have to find the least common multiple, or the LCM, of the denominators to find your least common denominator. So let's review how to find an LCM. To find the LCM of 5 and 6, let's find the multiples of 5 and 6. So the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, and so on. The multiples of 6 are 6, 12, 18, 24, 30, 36, and so on. What is the smallest multiple that these numbers have in common? 30. So our least common multiple of 5 and 6 is 30. Let's try that again for the second one. I want to find the least common multiple of 6 and 15. Well, we just found the multiples of 6. They are 6, 12, 18, 24, 30, 36, and so on. The multiples of 15 are 15, 30, 45, 60, and so on. what is the least common multiple that they have in common? Well, they have 30 in common. So here, the LCM of 6 and 15 is 30. So for example 4, they're having us find the LCM of two polynomials. And we have 2 steps given to us to help us find the least common multiple. Step 1 is to factor each polynomial. My first step when factoring is always to look for a GCF. For the first polynomial, x cubed minus 9x squared, I do have a GCF of x. When I factor that out, inside parentheses, I'll have x squared minus 9. I can continue to factor this. X squared minus 9 is a difference of 2 squares, and so I can factor that as x plus 3 times x minus 3. For the second polynomial, there is not a GCF. I have a quadratic trinomial, and so I am going to factor that using the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. Here I am looking for factors of negative 15 that add to negative 2. Those factors are negative 5 and positive 3. The greatest common factor on my top row is x. The greatest common factor on my bottom row is 3. The greatest common factor in my left column is x. And the greatest common factor of my right column is negative 5. So this one factors into x plus 3 times x minus 5. Step 2 says the least common multiple is the product of the factors. So let's see. I have x as a factor, and then I have x plus 3 as a factor. Now both of these have x plus 3. It only occurs once in each of these factors, so we only need to have it once here. I also have x minus 3 as a factor. And then for the other polynomial, we already have the x plus 3, so now we need to include the x minus 5. So my least common multiple for x cubed minus 9x and x squared minus 2x minus 15 is going to be x times x plus 3 times x minus 3 times x minus 5. This is my answer. We need to know how to find the least common multiple because that will be your lowest common denominator when you have fractions that do not have a common denominator. The least common denominator, the LCD, of 2 or more fractions is the LCM of the denominators. To write rational expressions in terms of their LCD, you will first want to factor each denominator, then find the least common multiple of the denominators, and then multiply the numerator and denominator of each fraction by each factor of the LCD that is not already a factor of the denominator in the fraction. Let me show you what that means. On example 5, it says add. The first thing that I want to do is I want to identify the least common denominator. Both of these denominators are already completely factored. There is nothing that I can factor in x plus 3 or in x plus 7. So my least common denominator is going to be if I put those two denominators together. So that would be x plus 3 times x plus 7. So now that I know what my LCD is, what I'm going to do is multiply each fraction by what factor it is missing. This fraction has x plus 3, so it's missing the x plus 7. So I'm going to multiply this fraction top and bottom by x plus 7. This fraction has x plus 7. It's missing the x plus 3. So I'm going to multiply this fraction top and bottom by x plus 3. So right now in my first fraction, I'm going to have x plus 7 times x plus 3 in my denominator. And in my numerator, I'm going to have to use a distributive property. 5 times x is 5x, and 5 times 7 is 35. Plus, in my second fraction, my denominator is x plus 7 times x plus 3. And in my numerator, I'm going to have to distribute. 6 times x is 6x, and 6 times 3 is 18. Now that I have a common denominator, I can add my numerators. So my common denominator is x plus 7 times x plus 3. In my numerator, I'm going to combine like terms. 5x plus 6x is 11x. 35 plus 18 is 53. There is nothing else that I can simplify here. This is my answer. Let's try that again with example 6. It says add 2 over 3x plus 4 plus 4x squared minus 11x minus 12 divided by 6x squared plus 5x minus 4. First thing I'm going to do is I'm going to simplify everything. This first fraction has nothing to factor, so that one's already as simplified as it's going to get. For my second fraction, don't worry about your numerator just yet. Let's just focus on the denominator. So I'm going to look at this part right here, and I'm going to factor that. There's no GCF, so I'm going to go ahead and go straight to the area model. First term goes in the first box, last term goes in the last box. You always want to multiply your first number by your last number. Here I'm looking for factors of negative 24 that add to 5. Those numbers are going to be positive 8 and negative 3. The greatest common factor in my top row is 2x. The greatest common factor in my bottom row is negative 1. The greatest common factor of the right side is 3x, and the greatest common factor, or the left side is 3x, and the greatest common factor of the right side is 4. So this denominator is now 2x minus 1 times 3x plus 4. Now that my denominator is completely factored, I can go ahead and find my least common denominator. Well, both of my denominators have a 3x plus 4. This denominator is missing this part right here. So it looks like this entire denominator on my right fraction is my LCD. So my least common denominator will be 2x minus 1 times 3x plus 4. That means that I just need to multiply this fraction, top and bottom, by the part that it is missing, which is 2x minus 1. This fraction already has both of those factors in the denominator, so this one's already simplified. So in my left fraction, I'm going to have in my denominator 2x minus 1 times 3x plus 4 in my denominator. In my numerator, I'm going to multiply by using the distributive property. 2x times 2x is 4x squared. And 2x times negative 1 is negative 2x. In my other fraction, I'm going to go ahead and leave all of that the same because it already has our common denominator. Now that I have a common denominator, I can go ahead and add my numerators. So I'm going to have 2x minus 1 times 3x plus 4 in my denominator. And then in my numerator, I'm going to go ahead and combine like terms. Let me use a different color. 4x squared plus 4x squared is 8x squared. Negative 2x minus 11x is negative 13x. And then negative 12 doesn't have a like term, so I'm going to go ahead and bring that down. This is our answer. There is nothing left to simplify here. Now that we've talked about addition, let's look at subtraction. On example 7, there is nothing to factor, so my first step is going to be to find my least common denominator. My least common denominator here is going to be 2x minus 3 times 3x minus 1. In my first fraction, we have the 2x minus 3, so I just need to multiply by the 3x minus 1. And in my second fraction, we have the 3x minus 1, so I need to multiply by the 2x minus 3. So over here, I'm going to have in my denominator 3x minus 1 times 2x minus 3. And in my numerator, I'm going to have to use a distributive property. So I'm going to have 6x squared minus 2x minus, and then in my second fraction, I'm going to have 3x minus 1 times 2x minus 3 in my denominator. And in my numerator, I'm going to use a distributive property to get 8x minus 12. Now that I have a common denominator, I can go ahead and subtract. My common denominator is 3x minus 1 times 2x minus 3. So my first numerator can just go ahead and come on over. And for my second numerator, I have to distribute this negative. Negative 1 times 8x is negative 8x, and negative 1 times negative 12 is positive 12. Now that I have distributed the negative, I can go ahead and combine like terms in my numerator. So let's see. 6x squared doesn't have a like term, so I'll bring that one down. Negative 2x minus 8x is negative 10x. And 12 doesn't have a like term, so I'll bring that one down. We can go ahead and factor out a 2 here. So I'll have 3x squared minus 5x plus 6. And that's going to be over 3x minus 1 over 2x minus 3. This is my answer. If we look at example 8, what we need to do first is we need to factor our denominators. So for this first fraction, I'm going to have 3x minus 5 over, this is a difference of 2 squares, and so I can factor that as x plus 5 times x minus 5 minus 2 over x plus 5. Now that I have everything factored, I can go ahead and find my least common denominator. My least common denominator is going to be x plus 5 times x minus 5. That is what I have in this first fraction's denominator. For the second fraction, I only have the x plus 5 part. So I need to multiply by the part that I'm missing, which is x minus 5. So in my first fraction, that one's going to stay the same as 3x minus 5 over x plus 5 times x minus 5 minus, and then in my second fraction, I am going to have to distribute. So 2 times x is 2x, and 2 times negative 5 is negative 10. Now that I have a common denominator, I can go ahead and subtract. My denominator is x plus 5 times x minus 5. My first numerator is 3x minus 5. And in my second numerator, I am going to have to distribute this negative. So I'll have minus 2x plus 10. Now I can go ahead and combine like terms. 3x minus 2x is x, and negative 5 plus 10 is positive 5. And that is over my denominator of x plus 5 times x minus 5. Well, it looks like I have a common factor in my numerator and my denominator. I both have an x plus 5. X plus 5 divided by x plus 5 is 1. So that means that I have 1 divided by x minus 5 as my fraction. This is my answer. And on my last example, I have x plus 1 over x squared minus 6x minus 16 minus 2x plus 1 over x squared plus 6x plus 8. The first thing that you want to do here is you want to factor your denominators. So in my first fraction, I'm going to have, let's see, where do I want to do this? I'll write it right here. So I'm going to have x plus 1 in my numerator. And in my denominator, I'm going to use the area model because there is no GCF there. First term goes in the first box. Last term goes in the last box. You always want to multiply your first number by your last number. So here I'm looking for factors of negative 16 that add to negative 6. And that's going to be negative 8 and positive 2. In my top row, my GCF is x. In the bottom row, my GCF is 2. On the left side, my GCF is x. On the right side, my GCF is negative 8. So this is going to factor into x plus 2 times x minus 8. Minus, in my numerator, I have 2x plus 1. And in my denominator, I'm going to factor this. Again, I'm going to use the area model. First term goes in the first box, last term goes in the last box. Here I'm looking for numbers that multiply to 8 and that add to 6. That's going to be 4 and 2. The greatest common factor of my top row is x. The greatest common factor of my bottom row is 2. The greatest common factor of my left column is x. And the greatest common factor of my right column is 4. So here I'm going to have x plus 2 times x plus 4. Now that my denominators are completely factored, I can go ahead and look for my least common denominator. Both of these denominators have an x plus 2. This denominator has x minus 8, and this denominator has x minus 4. So those are the factors that I'm going to have to multiply each of these by. So my least common denominator is going to be x plus 2 times x minus 8 times x plus 4. So this one is missing the x plus 4. And this one is missing the x minus 8. In my numerator, when I go to multiply this, here I have a binomial being multiplied by a binomial. You can multiply that whichever method that you prefer. You could use the area model, you could use distributive property, you could use FOIL. Whichever method you like the best. I'm going to use a distributive property. X times x is x squared. X times 1 is 1x. 4 times x is 4x. And 4 times 1 is 4. And that's over my common denominator. Well, actually, now I do have common denominators, so I'm just going to go ahead and do this all in one step. And so my common denominator is x plus 4 times x plus 2 times x minus 8. And then I have our minus sign. And then whatever I get when I multiply these together is all going to go inside parentheses here because I'm still going to have to distribute this negative. I am again going to use the distributive property here. 2x times x is 2x squared. 2x times negative 8 is negative 16x. 1 times x is 1x. And 1 times negative 8 is negative 8. Excuse me. So let's see what we have. My denominator is x plus 4 times x plus 2 times x minus 8. In my numerator, I'm going to have x squared plus 5x plus 4. And then I am going to distribute this negative. Before I do that, negative 16x plus x is negative 15x. So let's see. Negative 1 times 2x is negative 2x squared. Negative 1 times negative 15x is positive 15x. And negative 1 times negative 8 is positive 8. So from here, I am going to go ahead and combine like terms. And so my denominator is still x plus 4 times x plus 2 times x minus 8. And in my numerator, x squared minus 2x squared is negative x squared. 5x plus 15x is 20x. And 4 plus 8 is 12. This is my answer.